And let's continue with the fifth rule. The fifth rule says that if a logarithm is converted to a fraction as 1 over the logarithmic function, then the base and the power change rules like this. Let's move on to this question. This question is you are going to apply the fifth rule. As you can see, the powers are equal, so you can convert this into the original logarithmic function and write them into the same base like this. As you can see, now bases are equal and there's a plus in between, so you can write the powers as in a product form like this, and you get logarithm base 6 of 36, and 36 is, as you know, 6 to the power of 2, so it can be written like this, and this one is 1, so the answer is 2. Let's move on to the sixth rule. The sixth rule says that if the power of this logarithm, one logarithm, is the base of the next logarithm, then you can cancel out these factors, as you can see here, and you can write them into an independent logarithm. There's an easy example. As you can see, the power and this base is same, so you can cancel them out. And there's a one logarithmic function, so let's convert this like this. As you can see, I wrote them into a strict form, as the same form, and these terms cancel each other, so we only have logarithm a to the power of 2 in the base and the a in the power, so this is 1 and this power is 2, and you can write them like this, and logarithm a base a of a is 1, so the answer is 1 over 2. And now we are done with the rules of the logarithm, and we are just gonna solve random logarithm questions by now. So let's do this question. This question asks us the interval of x. In this type of questions, if the base of the logarithm is greater than 1, we are just gonna solve it like a normal logarithmic function, where we send the 5 here as a base and 1 becomes our power, and we will keep the inequality way same like this. And let's solve the inequality like we always do in the previous topics, like this. As you can see, x must be less than 2, but there is one more thing that we have to consider in logarithmic inequalities. That is that, like in the first video, we will find the interval where the power is greater than 0, because the power must be greater than 0 in order for the logarithm to exist. So let's find that interval. And according to that rule, x must be greater than 1 over 3, so let's sum up the inequality. And this is our interval. Let's solve this question. These types of questions are really important. We are gonna these kinds of functions where like there's 2 unknown terms and you cancel one and then you find the other terms like x and y. It's like that. As you can see, these logarithm y are equal, and if you write the logarithm x in the same way by taking this 3 into the front, we are gonna get it and two equations with 2 unknown and solve it by that like this. And if we multiply this equation with 2, we can cancel these factors out like this. And these cancel each other if we sum up the whole equation, and we get this. And the logarithm x is 1, we found it. And if we place the logarithm x, replace the logarithm x with 1, we will find the logarithm y. For example, as you can see, we canceled these factors out and then found the logarithm x, and then replaced the logarithm x with 1, and then found the logarithm y, like we do in the equations with the two unknown, like a normal question, but x and y is logarithm x and logarithm y, just this difference and nothing more. To this question, this type of question is also really important. It's asks us the digits. First of all, let's talk about digits. It asks us to find how many digits does this number have. If normally, like if we are asked to find the digits, we find how many powers of 10 are there, because digits are like goes like first digit is 10 to the power of 0, and the second digit is 10 to the power of 1, and the third 10 to the power of 2, and it goes on like that. So when we are asked digits, we work with the tens. So we have to find how many tens in this number. So we are going to write a basic equation like this, and we have to find the power. But since we can't do it with basic math because the bases are not simple, we are going to use the benefits of logarithm here. We are going to take the logarithm of both sides. And we are going to take this x into the front like this, and 50 into the front like this. And logarithm 10 is 1, as we all know, and logarithm 2 is given here as 0.301. So we have this simple equation here. If we calculate this part, it makes 15.05 equals to x. Now if we found x, let's rewrite this equation like this. 2 to the power of 50 equals 10 to the power of 15.05. If we check this equation, like we know that there is a power of 10 which is greater than the 10 to the power of 15, but also smaller than the less than the 10 to the power of 16. So it's in between the powers 15 and the power 16. So we know that there is like 0 at least, but not 16. It can't be 16. But also there's a coefficient, like not a coefficient, but like the leading term here coming like in one digit. So 0 comes here, and one digit comes from the leading term, like for example 9, but it can't be 9, I don't know, we don't know. So but we know that there's one digit and there is 0, so it makes 16 digits are there in the number of 2 to the power of 50. And let's move on to this type of question. This type of question is also an interval question, but this is different since the base is not bigger than 0. In those cases where a base is big, in between 0 and 1, we have another rule. Let me write that. As you can see in this part, if the base is in between 0 and 1, whole thing is opposite. Like normally, if since the base is greater than 1, it must be fx must be like less than gx, the same with this sign. But since it's in between 0 and 1, it's opposite like this, and fx is greater than gx. We solved this type of question previously, and now we are faced with this type of question, and let's solve it to understand more. As you can see, this is in between 0 and 1, so whole thing is different. Let's send this base to the here as the new base like this. And now, since the sign must be opposite, we convert it into the opposite side, and let's solve the equation like we normally do. And now we get this interval for x now, but we also need to make sure that these powers must be greater than 0, so we also check that. And now we learn that x must be greater than 4, and now we just write our interval for x. Now, as you can see, x must be greater than 4 and must be equal or less than 11. So let's continue with this question. This question is a graph question, as you can see, and the graph increases by increases, so this might be a logarithmic function, but we will check that out. We are going to write a basic logarithmic function, and we will find the base and power by looking at the graph. Let's write our logarithmic function. As you can see here, there's a vertical asymptote at a, which means that if we put 8 instead of x, the function is not defined. So if you write here x minus 8, if we place x with 8, then the logarithmic function doesn't exist because because the power must be greater than 0. So we've found this factor, and let's look at a. As you can see, the graph cuts the x and y axis at the point where x is 10 and the y is 1. So let's solve them. 1 equals logarithm base a of 10 minus 8, which is logarithm a 2. As you can see, for this logarithmic function to be 1, a must be 2, which is same with the power. So our logarithmic function is logarithm base 2 of x minus 8. So this is the function of this graph. You have to know how to analyze the graph of logarithmic function, because this is also an important type of question. And let's move on to this question. This question says find the product of the roots of the function. But first of all, we have to find the roots. But if you check the equation, like we can't cancel out any factors because there's a secret e. We can't cancel them out. So if we are stuck like this, what we are gonna do is we are gonna take the ln or logarithm of the both sides, but we have ln here, so we are gonna take the ln of the both sides like this. I'm gonna write the new equation. As you can see here, this power can go to here like this. And since the power is in a product form, you can write it separately in a addition form. And if you check, there's a bunch of ln x's. If we replace ln x with an unknown like this, ln x is equals to a, we can solve it easily without having to work with hard numbers. We're going to write a instead of x, so this is a square equals, this comes to the front, and ln e base e of e is 1, so this is 12 plus a. And we have a second degree equation, and we're going to solve it by finding two roots. And we have two roots, but be careful, these are not the rules of the ln. These are not the real roots. We find the roots of this second degree equation. These Since a is ln x, we are gonna find the real roots. And since there is a secret e in the base, we are gonna solve it normally like this. And these are our roots, and the questions wants us to multiply them, so we're going to multiply them, and this is a to the power of 1, which is e. The answer is e. Let's move on to this question. This question is a previously asked question, so this is important because it was asked before, and you might face it again. If we solve it, like this is 3 to the power of 2 and this is 2 to the power of 2, so the powers cancel each other, so this is just logarithm base 2 of 3, and this is same logarithm 2 base a of a minus 3 less than 4. And since this is in a multiplied form, you can write them into a product form like this. And now we have an inequality, and this is greater than 1, so you just take this here as a base without converting the sign in opposite. So when we solve our inequality, it says that a must be less than 8.333, and it goes like this. But there is one missing thing in the question, that the question must have said that the values must be an integer. So since a must be an integer, it may be like less than 8. We can write it like this. But we also have one more thing to check. It is that this 3a negative 9 must be bigger than 0, since it's a logarithmic function. So we have two boundaries, and let's write it into one inequality. So it's our interval is that, and if we find the integers in that interval, we can write this set. So we have 1, 2, 3, 4. And now let's move on to the last question. The last question asks us, says that draw the graph of y equals logarithm base 9 of x minus 4. So let's draw our axis. This is our x-axis and this is our y-axis. And if you check the power, when x equals 4, it makes the logarithmic function unexistent. So there's a vertical asymptote at x equals 4. And one more thing, we have to find the value where the graph cuts the x-axis. For that we are going to write 0 instead of y. So let's make that equality. If we put 5 instead of x, it makes, and logarithm base 9 of 1 makes 0. So when x equals 5, y equals 0. So let's also sign that. And since the base is greater than 0, the function is an increasing function. So our graph will be increasing and cutting the x-axis at x equals 5. but will not touch the vertical asymptote at x equals 4, so it becomes like this. So this was our last question. I hope you enjoyed our video and learned something from us and learned about logarithm. I tried to give all type of questions and explain all the rules. I hope you liked my videos. So see you